So today we are going to learn about vectors. In our previous lesson, we have learned that vectors have both the magnitude and also direction. It has magnitude and direction. So today we are going to represent our vector with an arrow, where if we have a vector force, this arrow is going to represent our vector. Let's say if we have a vector force F, we can draw an arrow to indicate the force, such as, for example, we have 10 Newton force applied upwards. So I'm going to use my arrow here to represent my 10 Newton force. F bar indicate a vector of 10 Newton upwards. So this length of the arrow represent the magnitude, and the head of the arrow represent the direction of our vector. Same case here, this is my magnitude and this is my direction. So the vector that we learn that has both magnitude and direction can be represented by just an arrow which has the magnitude and also direction. Okay, next we are going to look at addition of vectors. Let's say we have two displacement. Let's say you are moving two displacement, such as you move 5 meter to the right. So you move 5 meter to the right, and then you stop, you meet your friend, and then you were talking and everything. After that, after you said bye to your friend and you continue your journey forward still to the right for another 10 meter. So, if the question was, what is the total displacement made by you? We are going to simply sum these two. To get our total displacement is 15 meter. In which direction did you move? Because displacement is a vector. So, you move to the right. 15 meter to the right. Let's say now, after you have made this 15 meter to the right journey, you're going to U-turn and return back by 17 meters. By 17 meter. So now, what is the total displacement made by you? You initially made 15 meter to the right, and then you return the journey by 17 meter. So your total displacement now is going to become 2 meter to the left. So this one indicate the direction left. How did we deduce it is 2 meter to the left? Such as you moved initially 15 meter to the right, and then you return your journey by 17 meter to the left. So you're going to sum these two vectors. So your 15 meter to the right here, right gives you a direction of positive, plus with 17 meter, left, negative here gives the direction of left. So every time you move right and upwards, it is a positive sign, represented by a positive sign. And if you move left and downwards, it is represented by the negative sign. So when you sum them, you're going to end up with a negative 2 meter. And this negative 2 meter is not negative as in literally the max term negative. It is the direction that we associate to our left. Because we associated positive here to right and negative here to the left. Therefore, our total displacement now is only 2 meter to the left. Okay, as you can see, all your movement now are along the same component, which is the x component, because you're moving to the left or to the right. So it is only along x component. Same if you were to move 5 meter upwards. Let's say you move 5 meter up, and then you continue your upward movement by another 10 meters. So you continue to move another 10 meter up. So your total displacement here is going to become 15 meter up. Same thing, if you have made 15 meter upwards journey and then you return by 17 meter down, you're going to end up with 2 meter down. Okay, it is simply the same as your X component movement. Now you're only making the movement along a Y component. You're moving up and down. So now let's say if you have different cases, such as, let's say you are making a movement such as in the case below, you were to move in this direction, 5 meter, and then given that the angle is 15 degree. This displacement is described as 5 meter displacement in the direction of 15 degree north of east, or 5 meter displacement in the direction of 15 degree above the positive x-axis. Now let's say we are going to add another journey to this journey. So you have already moved 5 meter in the direction of 15 degree above the positive x-axis, and then now you continue your movement from this particular point where you stop. At this point, you're going to continue your journey in such a direction that you move in this direction now. No, let's say you move in this direction. It is much easier for me to show. Okay, this was 5 meter. This is another 15 meter, let's say, at an angle of 55 degree above the x-axis. So now this is your reference point. This is now your Cartesian plane of x and y. This one for the first journey, this is for your second journey. So at every journey you started, you can establish a Cartesian plane in order to show the direction where you want to use the angle above the x-axis. Okay, when we have cases like this, we cannot simply add our vectors, vector 1 and vector 2 here, like what we did for our previous case. Because the cases above, they were along the same component, thus we can simply add them. They were along x component, it's either they are moving right and right or right and left, or if they are along y component, they were moving up and up or up and down. Now we are moving in a certain direction where you have angles, angle in both the cases, which indicates that your vectors are in between both the x and y component. So for cases like this, we will have to resolve our vectors into component of x and y. After we resolve our component into x and y, then we can sum them separately, x with the x, y with the y. So for that, we have to first learn to resolve the vector. Now, to resolve vectors into x component and y component, we shall just take the example that I gave earlier, the previous example where we had 5 meter in the direction of 15 degree above the positive x-axis, and another journey of 15 meter at an angle of 55 degree above the positive x-axis. So to resolve, let us first look at the first vector, this one. Let us first look at this one, and we're going to learn how to resolve them. So to resolve them, it is always easy to transfer our vector into Cartesian plane. So you have x-axis and you have your y-axis. This is your x and y. So you're going to transfer this vector into your Cartesian plane without changing the direction. You cannot change the direction of your vector moving. cannot change. So your vector is pointing in this direction, which is in between north and east. So without changing the direction, you're going to transfer your vector where the tail of the vector has to always sit at the origin of your Cartesian plane. So this one here have to be shifted to this point. The tail here has to be shifted to this point, and then without changing the direction, you're going to produce your vector in the Cartesian plane, 5 meter, 15 degree above the positive x-axis. So now, this vector can be resolved into x component and y component, such as we are going to produce, let's say, I'm going to elongate my x component first. Let me elongate my x component first. This is my x component. X-axis, and then now I'm going to draw my dx, where when I break this vector into x and y component, I can get dx and dy respectively at this particular point. This is my dx and this is my dy. Dx to the right and dy upwards, as my resultant vector is sitting here. So my dx is equals to d cos theta, and my dy is equals to d sin theta. Sorry. Okay. Why is my dx is d cos theta and dy is d sin theta? Okay, if you resolve this triangle here into trigonometry, you will be able to deduce. Okay, so that will be your homework to identify how to deduce that. Other than that, you can just simply memorize. However, you have to be careful with the trigonometry used here. If your angle here touches the axis, therefore the axis that the angle touches will take cos. So now your angle 15 degree is touching your x-axis, maka x-axis akan ambil trigo cos. And the remaining axis, which is your y-axis, is going to take sine. We will only use cos and sine for resolving vectors. So now we are going to find out what is the value for my dx component, for my displacement along x component, which is actually 5 meter cos 15 degree, which is equals to 4.83 meter along x-axis. We have already deduced the direction just now. Here, this is the direction along x. And then for my dy here, I'm going to have 5 sine 15 degree. 5 sine 15, you're going to get 1.29 meter upwards here. We have already deduced the direction along y component. So this is your displacement along x and this is your displacement along y. This is what we call as resolving a vector into component dx and dy. So let's say now you were only given your dx and dy. Let's say what was given here is, this is your dx, given such that dx is equals to 4.83 meter, and then dy is equals to 1.29 meter. Dx is to the right, the arrow here indicates the direction, and dy is upwards, the arrow here indicates the direction. Let's say if I want to transfer this into Cartesian plane, I'm going to have my y component and x component. My dx here is sitting along x component, which is to the right. So I'm going to transfer the vector here. The origin is where your tail of the vector should be. And this is my dx with a value of 4.83 meter. And then this is my dy with a value of 1.29 meter. Okay, so when I have a vector along x and along y, I can find the resultant vector. The resultant vector, which is d, is equals to square root dx square plus dy square. This is what we call the magnitude of vector. So to find the resultant of dx and dy, we have to find the magnitude of the vector. So my d is equals to square root dx square 4.83 square plus with 1.29 square. I'm going to get 4.83 square plus 1.29 square. Square root my answer, I'm going to get 4.999, which is approximately to 5 meter. If you can see, this 5 meter was the initial vector given here. So can you see what I'm trying to explain here? You can split a vector which is in between the component into x component and y component to find the value along component. Also, at the same time, if given to you the vectors along x and y, you can also find the resultant here by using this magnitude method. However, since this is a vector, you have only managed to find the magnitude. You have not yet find the direction. So to find the direction, we use this equation. That is shift tangent is theta is equals to shift tangent summation of summation of y component over summation of x component magnitude. So your shift tangent summation of y, this is your y component, whatever value you have along y, 1.29 divided by summation of x, whatever value you have along x, 2.83. 1.29 4.83 shift tangent answer. So you're going to get 14.95 degree. If you round off, you're going to get 15 degree, which is actually the same as above, 15 degree. 15 degree, and this is a 5 meter. So this 15 degree here, how can you sure it is sitting above the positive x axis? How? So you go back and look at the summation y and your summation x tadi. Tengok balik dua ni. So your summation y was 1.29 and your summation x was 4.83. Okay, both your summation were positive. So your x was sitting in the positive x-axis and your y was sitting in the positive y-axis. Therefore, the resultant is obviously going to sit somewhere here. So the theta is always with reference to the x-axis. So this is what we call above positive x-axis. So that is how you deduce the direction as 15 degree above the positive x-axis. So in your Cartesian plane, if you have your resultant here, and this is your reference angle above positive x-axis, as this is your x-axis and this is your positive x and this is your negative x. And then if you were to have your resultant here, how do you deduce the direction? Use only x as your reference point. Maka you are going to take the angle here, this part. You're going to write as above negative x-axis. if anything below here, below negative x-axis. If anything here, below positive x-axis. So before we look further into the question just now, let us attempt an example on resolving vector. Look at example 3 on your notes. So you have a force of 800 Newton. So you have a force of 800 Newton exerted on a bolt A as shown in figure below. Determine the horizontal and vertical component of the force. So your force now is sitting in between your X and Y component. So we are going to establish a Cartesian plane at the point where our vector started. So from here we can see that the vector here is sitting in between the Y and also X axis. Therefore, what is going to happen here is the question asks us to indirectly resolve, but they use the term horizontal and vertical component. They did not use fx or fy. The horizontal component here means your vector along x, and your vertical component here means vector along y. So now we are going to resolve our vector such that you have F 800 Newton at an angle of 35. So to find our Fy vertical component and also Fx horizontal component, we have to resolve. So your Fx is equals to, before we start, let us look at our angle here. The angle here is touching the x-axis. Therefore, the x-axis is going to take 3 go cos and y-axis is going to take 3 go sine. So my Fx here is going to be 800 cos 35 with a negative in front here to indicate the direction the vector is pointing, which is to the left. And then when you press your calculator, you're going to get negative 800 cos 35 is equivalent to negative 655.32 Newton. And your Fy here is going to become 800 sine 35. It is positive as it is pointed upwards. 800 sine 35 is equals to 458.86 Newton. So this is your horizontal component of the force, and this is your vertical component of the force. So coming back to the question earlier, we had 5 meter, 15 degree here, and then we have another 15 meter with 55 degree. The initial question was to find the resultant displacement. That was the initial question, to find resultant. Maksudnya you have to sum this first displacement with the second displacement in order to get our resultant displacement from the initial point here to the final point here. What is the total distance you have, as total displacement you have traveled? So for that is why I have explained to you that since both your vector here are not parallel to each other and they are not along the same component, therefore you have to resolve them in order to find the resultant displacement, such that you have to resolve into x component and y component, then find the summation along the component. So to find the summation along the component, we'll discuss this question and we'll show how to get that resultant displacement. So the first thing first is you will have to transfer these two vector 1 and vector 2 into Cartesian plane. So establish a Cartesian plane. So this is your, one second, let's label as this is displacement 1 and this is displacement 2. So now we are going to start with the first step here is to establish a Cartesian plane. Y axis, X axis. Okay, so now you're going to transfer every vector in the question into the Cartesian plane. So to transfer them from the question into the Cartesian plane, all your vector has to start from the origin. All the vector has to start from the origin, and you have to transfer them into the Cartesian plane without changing the direction. So your first vector is going to sit in this place without changing the direction, which is 15 degree 5 meter, my D1. And then my D2 here, this one now, I cannot change my direction. It is pointing in between north and also east, north and east, and this tail of the vector has to sit at the origin here. So I'm going to draw somewhere here. This is my D2 with an angle of 55 degree and displacement of magnitude of 15 meters. So this is my D2. So for us to sum these two vector, next what are we going to do is we are going to have table being associated to this Cartesian plane. We are going to transfer whatever in the Cartesian plane into the table. We're going to transfer this into the table. So the table here, what you should have is, you should have your vectors, X component and Y component. You're going to resolve both the vector D1 and D2 into X and Y component so that you can sum them along X, X with X and Y with Y to get the summation of X and summation of Y. So D1 was initially sitting here. This is your D1. This is your D1. So you have to resolve this D1 into D1X, which is 5 cos 15. Alright, 5 cos 15, and your dx here is to the right. So positive 5 cos 15. The positive here is because the direction is right. And then you're going to draw your D1y now. Your D1y is going to sit somewhere here. This is my D1y when I resolve. So I'm going to end up with positive 5 sine 15. Positive is because it is upward. Next, my D2 here has to be resolved into D2x. This is my D2x and this is my D2y. So my D2x will have a positive still because to the right, 15 cos 55, and my D2y is going to become positive upward 15 sine 55. So what you do now, you're going to total these two. You're going to add 5 cos 15 with 15 cos 55. You're going to add them in order to get the summation of x. 5 cos 15 plus 15 cos 55. Make sure your calculator are in degree mode. So you're going to get 3.43 meter. And then now you're going to do the same thing for your y component. You're going to sum d1y with d2y. 5 sine 15 plus 15 sine 55. So you will end up with 13.58 meter. So whatever value you have obtained is along X and along Y. Now you can find the resultant displacement's magnitude. So magnitude of D for both these two vectors, D1, my D1 and my D2, my D1 and my D2, the resultant D magnitude would be summation of dx square plus summation of dy square. So the summation of dx square is 13.43 square plus with summation of dy square 13.58 square. Square root 13.43 square plus 13.58 square will end up with square root 19.10 meter. So this is my magnitude of resultant displacement. Okay, so next kita nak cari dia punya direction sebab ini baru magnitude sahaja. Direction kita guna kaedah theta is equals to shift tangent summation of y component over summation of x component. So dalam kita punya ni equation kita, dalam soalan kita summation y kita adalah ini dan summation x kita adalah yang ini. Therefore kita akan masukkan nilai dia 13.58 divided by 13.43. So tekan calculator, 13.58 divided 13.43, shift tangent kita dapat 45.32 degree. So apa yang kita dapat ini baru angle sahaja, belum direction. Literally tak indicate di mana dia duduk dalam kita punya quadrant itu. Mana dia duduk, first quadrant ke, second quadrant ke, third ataupun fourth quadrant. So for that kita lukis balik a small Cartesian plane dekat sebelah sini. Okay, so this is X, this is Y, and then kita masukkan Y kita dan X kita ni daripada summation ni, dia duduk dekat mana dalam kita punya Cartesian plane ini. 13.58 is a positive Y axis, so dia akan duduk dekat sini atas 13.58, dan 13.43 untuk X axis pun positif, so dia akan duduk dekat belah kanan sini. So bila kamu punya X dan juga Y adalah positif, maka resultant kamu akan duduk dekat first quadrant. Therefore angle yang kita dapat adalah angle dekat sini, which is above the positive X axis. So kita pun dapat above positive X axis, which is actually the first